Hello everyone. Today we are going to continue with our discussion on one unknown and one equation, and we are going to make things go a bit more advanced. Okay, so this time, following on what we had on the concept video, I'm going to have another example. Okay, so let's suppose I have this problem. So I have two boxes of x. Okay, so I have two boxes of x that have some apples in them, and if I add 6 apples to the number of apples that I have in these boxes, I will get 12 apples in total. Okay, but now remember, these two boxes are identical, so whatever apple I have in this one, I also have in this one. So they're not having different number of apples in them. So whatever is in this guy is in this guy. Kind of think of it as I copy pasted this box from here to here. Okay, so I can make this equation similar to the way that we had in the basic video as this equation representing this big picture equation. Okay, so I know box x plus box x make 2 box x, so I write it as 2 of these box x's plus 6 have made total of 12 apples. Okay, now I'm writing this equation here, and if you remember from our intermediate or our basic video, we can solve this equation by following few steps. So I can take this guy, we found this method to work best and fastest, and bring it to this side, but change the sign to the opposite of this, which is negative. So if I do that, I get 2x equals 12 minus 6, which is 6. Okay, all right, this is what we learned from last video on basics of one unknown one equation. How I solve this equation? Pretty close, but not yet. Okay, as you can see, I have the answer in the form of 2 of box x's. So 2 of box x's have total of 6 apples in them. What is the number of apples in one of them? I can again, just like the concept video, use different numbers 1, 2, 3, and I will eventually reach that 2 of, if box x has 3 apples in it, 2 of that, 3 plus 3 makes 6. Remember, this 2 box x was 1 box x plus 1 box x, so 3 plus 3 is 6. Okay, but again, I'm going to follow the same step that we developed in the basic video and come up with a very advanced way of doing this instead of by trial and error with one single step. Okay, so what I'm going to do is similar to the one we had in this guy. I'm going to take this number, bring it to this side, but I'm going to do something else with it. Okay, so remember, 2 times x, 2x, this thing, 2 times the box x can be written as 2 multiplied by box x, right? So what I'm going to do is take this 2 to this side and do the opposite operation, which is in this case division. So if I do that, I get 3, or I can write it this way: 6 divided by 2 is the number of apples in box x, which is, I can write it also with the fraction line, and I get 3. All right, now let's solve 2 quick examples. Okay, so the first example is of the type we just solved, 2x plus 5 equals 10. First, what I'm going to do is I'm going to take this 5 to this side, and then I will take the 2 to this side. So if I take 5 to the other side, I get 2x equals 10 minus 5 equals 5. So 2x equals 5. Then I will take the 2 to the other side. So I will take, so from this, I got 2x equals 5. And then I take this 2 to this side and do the opposite, which is division. So I get x equals 5 divided by 2, or in this form, which is equal to 2.5. All right, for the equation on the bottom, okay, again, I'm going to take 5 to the other side. I get 10x minus, this is similar to the one we had with the opposite operation on the first guy. Okay, so I take 5 to the other side, I get x over 3 equals 10 minus 5, which is 5. And now I have to do inverse of this operation, inverse of division, which is in this case multiplication. So I get x equals 5 multiplied by 3, which is 15.